Today is going to be a rather short lesson, and we are going to be learning how to add radicals. And to show you how to add radicals so it doesn't look like we're teaching you something completely new, let's go back on how to add variables. We can add x and x and x, but we can't add the y. Okay, so I can 5x plus 3x is 8x. Minus 2x would be 6x, right? And that's where you stop. Because you can't add y, and there's nothing to add y to. That comes under like terms. We're going to be doing the same thing, or something very, very similar, with radicals. So this is very similar to last time, except that we're adding roots instead of variables. And we have 5 root 11 plus 3 root 11 minus 2 root 11. And that's going to be 5 plus 3 is 8 minus 2 is 6. And the answer is going to be 6 root 11. And we would not be able to do this if one of those roots was 10 or 8 or 9 or anything else. We can only add these. You treat them like variables. They're not variables because we know what the value is. Root 11 is an actual value. X is not an actual value unless we're solving for it and we find out what x does equal. But we use x because we don't know what the value of a term or factor is. So the only way we can add roots is if they're all the same, and it has to be the same root. Okay, so they all have to be square roots or cube roots or fourth roots or whatever. Now we're not going to get into the higher roots because that's starting to sneak into Algebra 2, and so this is about as difficult as it's going to get. But let's try something else. Okay, in this problem we're going to do the same thing. We're going to add the roots, and if you look at that you're going to say, well, every one of those roots is different, and so we can't add any of them. That's your answer. No. What do we have here? We have some roots that can be simplified. So why don't we do that? And I'll tell you what, why don't we add down instead of add across, and that'll give us more room to simplify these. Good. Why don't we start with the first radical and tear apart that 45? Well, that's better. Grab the twins and take them out. And that'll be 3 times 5. And we're going to have 5 left under the radical. Good. 3 times 5 is 15. And let's tear apart that 18. We'll have 3 times 6. And we'll have a 2 left under the radical. 3 times 6 is 18, and let's tear apart this 98. 2 times 7 times 7. Let's grab the twins and take them out. And I'll have 7 times negative 2 with the 2 left in the radical. 7 times negative 2 is negative 14, and let's tear apart this 20. And that's 2 times 2 times 5. Let's take the twins out. And if you remember, we didn't have a coefficient in front of the root 20. So when we take the twins out, it's just going to be 2 times root 5. Okay, now we're in a position to add common radicals. And let's see, we have a radical 5 here and a radical 5 here. Those are the only two that we have. So that would be 17 root 5. So we've added the first radical and the fourth one, and all we have left are the second and third one, and they are common. We can add those since they're both radical 2. So 18 minus 14 is 4 root 2, and that is our answer. 17 times the square root of 5 plus 4 times the square root of 2. Now let's try one more thing. What is the square root of 80 million? Now that is nowhere near as bad as it looks. And we're not going to tear it apart like we did the other radicals. That is, in the other radicals, we always tore it down into prime factors. But let me show you an easy way to do this, because if you do that, and you can, it's just going to be an incredible amount of work, and you're going to have to be multiplying and doing all sorts of things to make sure that you not only get it down to the prime factors, but to check your work and to make sure that it was 80 million. Let me show you something simple. We're going to take off these zeros 2 at a time. Why? Because if I take off 2 zeros, that represents 100. That is, I've divided this whole thing by 100. Well, what's 100? Well, it's 10 squared. So if I take 2 zeros out, I'm going to put a 10 here. Okay? It's going to be kind of like grabbing the twins and taking them out. Okay, that worked out pretty good. Why don't we take the next two? And remember, we're starting at this end. Let's take the next two. Good, and remember that every time we take 2 zeros out, it's going to be not 10 plus 10 or something crazy like that, but it's going to be 10 times 10. So let's take 2 more zeros out. Good, and let's grab the next 2 zeros. Oh, there's only one left. Okay, well, we can't grab it then. You have to grab 2 zeros at a time. Don't grab out 1 zero and call it a 5 or something crazy like that. So this part of the job is done, so why don't we just bring that down. And as you can see, what we have left is 1,000 times root 80, but we can still tear apart the 80. That is not completely reduced. Let's tear apart that 80. Good, and we have 2 sets of twins, and I know they're all the same. It's 2 times 2 times 2 times 2. And but we're going to treat them as twins because just like the zeros, we take them out 2 at a time. And so let's circle the twins and take them out. Good, and that will be 2 times 2 times 1,000, and we will have a 5 left in the radical. And that's the answer, 4,000 root 5. And that's everything you need to know for this lesson. Do your homework.